皆さん、ようこそ UoC へお越しくださいました。UoC でプロデューサーをしています、里江です。今日はどうもありがとうございます。少し頭の方、最初だけ私の方から UoC について簡単に説明をさせてください。ここ、ユニバーシティオブクリエイティビティは2020年に、開設されました。人類のAI、ビッグデータ、様々なテクノロジーが活用されていく中で、人間に残された資産は何だろうか。それは創造性だ。ということを、念頭においてこの大学は作られています。様々な、社会課題がある中で、私たちの創造性を使ってどうやって新しい未来を描いていくことができるのか、それを日々私たちが様々な人と対話をしながら研究を行っています。今日は、その研究の中で、とても嬉しい出会いがありまして、東京大学の、豊田さんとの出会いと、小渕教授との出会いがありまして、今日この場を開かせていただくことになりました。そしてここに、マスティアスさん来ていただいて、Welcome to UoC ありがとうございます。ここで皆さんと一緒に新しいこれからの建築についてお話が伺えるとお聞きしています。とても私も楽しみにしています。今日この時間、皆さんの創造性がたくさんの刺激にあふれて、また次の未来を一緒に描ける仲間として、ここから一緒に歩んでいけることをとても楽しみにしていますので、皆さん今日はどうぞよろしくお願いいたします。それでは、早速ですけれども、もうお渡ししてもよろしいですか？はい、よろしくお願いいたします。
はい、東京大学の小渕です。よろしくお願いします。ですね、マティアス先生、もう写真を入れちゃっていいかな。マティアス先生の、講義はいつもすごく研究者向けのレクチャーなんですけども、今日はこういった形でインフォーマルにいろんな形でディスカッションができるという場をいただいてとてもありがたく思っております。それで始める前にざっとですけども、デジタルファブリケーションっていうのはどういうものなのかっていうのを知ってる方、ちょっと手を挙げてください。デジタルファブリケーション。半分くらいかな。半分みんな知ってるかな。今日のお話はマティアス先生なんですけども、ものづくりをどういうふうにコンピューターを使いながら展開していくのかというお話です。そしてここの写真にざっと彼のちょっとあんまり画像が良くないんですけども、これ2010年にマティアスさんは建築家でもあり、大学での教授でもあり、スイスの工科大学チューリッヒ校なんですけども、それと同時に研究者という形で NCCR っていう、スイスの国家プロジェクトでデジタルファブリケーションをどういうふうに展開していくのかというところの創設者でもあるという研究者、教授、それと建築家という方がこういう巨大なロボットをアームを大学の施設で買って、でそれまではですねレーザーカッターとかまたミリングマシンとかそういった小さい模型を作るということに建築家またはその教育の関係者がいろいろ実験をしていたんですけども、突然こういう巨大なロボットを使いながら実際の施工をしてみる、多分今日お話でたくさんの写真とか事例が出てくると思うんですけども、今までにないようなそういった研究の仕方っていうものを2010年ぐらいからもうずっと展開されてきているというので、今日のお話はロボットがどういうふうな形で建築の施工、最初は施工をどういうふうに新しく考えていくのか、そしてコンピューターとものづくりっていうのをどういうふうに掛け合わせるのか、または情報ともの、実際の建物っていうのをどういうふうに連動させるのかとか、そういうふうなお話をいろいろさせていただいて、で最終的にはやはり我々の今の時代っていうのはいろんな社会問題っていうのがありますよね。例に言うと環境問題、そういうことに対してもじゃあデジタルと建築またはこういうデジタルファブリケーションっていうのがどういうふうに関わっているのか、またはどういうふうな形でそれが何かな新しい発想を持って新しい研究にまた展開できるのかというようなお話を今日マティアス先生とディスカッションをしたいと思います。じゃあ今日よろしくお願いします。So with that, sorry, I guess you didn't get any translation. So, but 英語で話してもらうので、けどディスカッションは英語なんでヘッドセットが必要な人はよろしくお願いします。Okay, with that, I just explained about how great you are, and we're gonna have a discussion afterwards your presentation. So with that, please join me welcoming Matthias 先生。
Thank you very much.
皆さんありがとうご
Here
ざい
it's a
ます。
very exciting place. It's my first lecture in SOX.
今日のレクチャーするのは初めてなんですが、今日はありがとうございます。
University of having me. Thank you, Yuzuki, for the introduction, and hope we're gonna have
UoC にインバイトありがとうございます。ユースさんも紹介もありがとうござい
I'm an
ます。
architect, and before I was an architect, I was a kid at one point. I was a
私、
teenager.
こんな大きいですけども、もちろん私も子供だったことがあ
And
っ
on the
て、
computer, I discovered, well, you could do gaming. So I liked that a lot. And then I realized, oh, I could actually maybe program and design my own computer
コン
game.
ピューターを使って最初はもちろんゲームだったんですが、
15 and 18. And so I
15から18になってだんだんプログラミングをするようになってきて、
do your own things. You can create things.
で、プログラミングをするといろいろと面白いことができるわけですね。
Software is a bit boring because it's you write software
でもその当時コンピューターはそんなにパワーがなかったので、
and then your software is gone.
ソフトウェアっていうのはやっぱり制限でそんなに面白いことまだできなかったと。なんかそこに限界を感じてしまったわけですね。で、そこでやっぱり建築というのを始めて、建築面白いじゃないかということで建築の道に入ってきました。
Do with the computer, what can you do?
でもやっているうちに
Real physical space with
建築で物理的な世界を作るということと同時にコンピューターで何ができるかということにも同時に気づいていて、それをどうやって一緒にできるかということを考えるようになりました。
entirely. Some work which we do particularly in the research context, but as you can see, we found also ways
今はそれを両方やるということで、大学でリサーチ、研究をやっていて、で当然デザインの仕事もやってますと。で、今日はそれを両方とも紹介したいと思います。Computational Design for Sustainable Architecture。コンピューテーショナルデザインをどうサステナブルな建築に使っていくのかということについてです。
in itself. And sustainable architecture, everyone
コンピューターを使うということはもちろん一つのカテゴリーですし、サステナブル建築というのもこれもまた一つのカテゴリーですと。 全然違う方向性ではあるんですが、この2つをどう、統合していくかということに関して今日お話ができればと思います。なかなかフォーマットにするっていうのは難しいんですけれども、これをこう統合する試みが一緒にできればと思います。
collaboration. I mean,
例えばこのイメージから始まりたいと思うんですが、こう人とマシンのコラボレーション
really well.
ということが僕らがやっていることわけですね。
There's a lot
日本はこれの分野の一つの最先端でもあるわけですけれども、
potentials of technology, and I think for us it's very interesting to actually scout about this collaboration and see what are the
この物理世界のものづくりという部分とコンピューターということ、これを2つつなぐということの、人間と機械、人間とコンピューターのコラボレーションということの
few
可能性を今探っているわけで
came
す。
out from research to show you a bit what that
最初のプロジェクトですけれども、ガンデンワインヤードの、建物、これはだいぶ昔のプロジェクトですもん。
facade.
この時はワインヤードの倉庫、ワイン倉庫のファサードのデザインをしたプロジェクトです。
This facade, as you can see, has these large, oversized
このファサードを見ると、よく見ると、見ていただくと分かるように球体のパターン、これグレープ、ブドウの粒なんですが、見えてると思います。これをどうデザインするかというときに、この当時は、絵を描いただけではなくて、もしくは写真撮ったわけじゃなくて、こうやって物理シミュレーションをしたわけですね。ブドウの一つ一つの粒に見立てた球を落としていって、この仮想のワインヤードの箱の中に落としていくと。で、この大きさ、もちろんバラバラなんですが、この建物に全部埋まるように落としていくと、こうやってあるパターンで入っていくと。で、この溜まった状態を横から見た画像をそのままこのパターンに落とし込んでいって、各方面から見た状態をこのレンガの陰影に映し込んでいるわけです。レンガは全部同じ面にあって立体的なわけではないです。単純にレンガの回転の角度が少しずつずれていて、その角度によって影の出来方が変わってきます。 それに応じて陰影をつけて全体をグラフィックのパターンに落とし込んでいくということをやっていくわけですね。なので、立体に無理やりするわけじゃなくて、あくまで平面の単純な、モダンな形なんですけども、でもそこにはちゃんとレンガのテクスチャーがあって、でもそのレンガならではの陰影の、強弱が一つのパターンという違う質を持つということをやってるわけです。この微妙な角度の調整をする上で、ロボットアームを使っています。角度を厳密に、つなげていかなきゃいけないわけで、この時のロボットアームの使い方っていうのは、まずは糊の付け方ですね。これがパラメトリックに使われているわけです。で、それの一つ一つの次の、レンガとの組み合わせの位置に合わせて糊の付け方が変わってきて、それが厳密な位置と角度に置かれていくということをやっています。やっていることというのは位置と角度の調整だけなんですが、レンガの物性とパターンの物性とが非常に強く見えてきますよねと。でこれは当然プレファブで工場で作ってきたパネルになるので、それを現地に持ってきて並べるということをやっています。ワインの倉庫というのは通気性が必要なので、それもこのレンガのレースのようなパターンの一つの機能的な効果になります。で、ローテーションがきついところでは向こうの透過性が上がりますし、横向いているところではほぼ見えなくなると。パターンというその意味以上にも、そのものの見え方、レンガの素材の見え方というのがその角度とかパラメーターによっても変わってくるというのもこの時の非常に面白い側面でした。次はシークエンシャルルーフというプロジェクトですね。今、ETH の、マチアス・コーラーさんたちを含めた7つの、研究室ですねが共同で使っている研究施設のこの屋根の、設計と、施工のプロジェクトになります。この屋根見ていただいて分かるように曲面になっているんですが、これ一つ一つ厳密に言うと、微妙に違う角度と長さでできている部材を厳密な位置につけていくというようなパラメトリックデザインの一つの形になっています。で、大きなフラットなビルディングなんですが、この屋根の凹凸、緩やかな曲面とパターンが一つの建物に対してのイレギュラーなリズムを作っていくということをやってるわけですね。もともとのアイディアは、硬い建物なんですけれども、布の、伸縮、引っ張った時に伸びたり、破れたりというようなことを、一つの形とパターンに落とし込むということをやりました。こういった、もともと硬い物質だったものを情報に持っていくことで、違う質を情報の中に織り込んで、本来の建築というものが持ってなかった情報に落とし込むということがデジタルファブリケーションやコンピューテーショナルデザインの可能性であるわけですね。こういうありとあらゆる物性とか素材感とかスケールとかそういった情報が全部一つの建築の構造物という形に落とし込まれると、この辺がコンピューテーショナルデザイン、デジタルファブリケーションならではの面白さになってくるわけです。この場合、やっている情報は非常に複雑なんですが、ディテールとしては非常に単純な簡単なことをやっています。 これが部分的な接着部分の大前になるんですが、それぞれの違う角度と形のものを厳密な位置で重ね合わせて、そこをこうビスで揉んでいきます。これを厳密にある位置でつなげていくことで、徐々に横にと展開して一つの局面を作ると。で、お互いに支え合っている構造体にしていくということをやっています。いろいろな情報をこの中に一つこう結晶させるというプロセスなわけですね。プロセスとしては非常に単純で、こうやってロボットアームである形に並べていって、でその位置を確定して、次のレイヤーが重なりを持ってレイアウトされていきます。でこのトラス状のものもくっついてきますと、並べていきますと。で今回は接着剤とは何も使わずに全部ビスで揉んでいくと。揉んでいくところもどこが重なっていてどこに打てばいいかということもあらかじめ計算してされているわけです。で最終的にはデータ通りに施工されたことを人間が確認して強度の確認をした上であるユニットごとに吊り込んで現場に施工されていくという形になります。こうやってデータがものの形になってあるユニットごとにクレーンで吊り込まれて一つのこうロボット、クレーンも一つのロボットですけれども、ロボットの能力を通して制御能力を通して建築の形になっていくと。ここの局面の形も非常に楽しいですけれども、我々がやっているようなコンピューテーショナルと一つの単純なユニットの組み合わせでもこんなスムースでクールな建物ができるわけですね。Yeah, I can hear it.
Okay. Good. Then the DFAB house,
これは次 DFAB ハウスというプロジェクトです。
which we built on another project which we built. So below here, structure here, it's called the nest building. The nest building is a building which we
ここに今見えてるベースの部分ですね。平らな床とただのスケルトンみたいなの、これをネストビルディングと言います。これをベースにしてリサーチ用にいろいろなユニットをこの上に継ぎ足していくということをやるための実験住宅です。今この段階ではそのネストという元の構造の上に3つ1、2、3、4左上が DFAB ハウスなんですが、いくつかそれぞれ違うプロジェクトとしてこのネストの上にそれぞれのテーマを持った実験住宅を組み合わせていくと、それをやるための住宅です。これは複数の ETH で進んでいる建築やファブリケーションに関するリサーチ研究を一つの建築の形に統合するという非常に野心的な実験プロジェクトです。我々がやったものの一つなんですが、これは曲面の壁を作ると。でこれをロボットアームで作るんですが、ここにちょっとカーテンのひだのような歪みをあえて作ってみると。硬い素材なんだけども柔らかい質感を作ってみるということをやっています。これ見てわかるように、これ鉄筋を曲面の形に厳密に曲げていくわけですね。こういう自由局面もロボットの厳密な制御によって作っていくことができます。当然鉄筋の構造体なので、構造として安定性にも寄与するんですけれども、新しい仕切りとしての表情っていうのも作り込んでいく要素にもなるという構造と表現が一緒になったような要素になってきます。
This is basically just a very small formwork into which concrete is filled.
この柱も、ユニークなデジタルファブリケーションの一つの例でして、通常の柱と違って下から順番にこうひねり出していきながら形を整えていくと。通常の 3D プリントとはちょっと違うこう型を抜きながらその型を徐々に変えていくというような、アプローチでの柱の、練り歯磨きのような、アプローチでのコンクリートの形の成形をやっています。見ていただくと分かるように出しながら徐々に固まるのに十分な時間をかけながらゆっくりと変形をさせていくとこういったユニークな形のコンクリートが 3D プリントの形でできるわけですね。この天井はまた、他の研究室 ETH の他の研究室がプロデュースした、パラメトリックな天井ですが、壁と、柱と天井それぞれが全然違うアプローチでもある程度の技術の共通性を持って作るということがここで一つの形に統合されています。テーマとしてはコンクリートの、デジタルファブリケーションなんですが技術をもしくはアプローチを変えることでそのコンクリートというのは全く違う形と表情を見せ始めると。そこには機能性を超えたいろいろな可能性があるんじゃないかということを今皆さんでやっているんだということですね。当然我々研究者だけではなくて建築家でもあるのでその技術と表現を統合するその表現というものにどういう可能性があるかっていうのにやっぱり最終的には興味があるわけですね。これはまた違うアプローチですが今度は木の軸組み構想なんですが候補なんですがこの直行形ではなくてこの斜めに支え合うような角材この長さと角度を厳密に加工してくっつけていくことである安定的な構造もしくは形を作っていくということを言います。これの背景としては最小の木材材料を使ってある安定的なバルーンフレームを作るということを最適化したとコンピューテーショナルデザインとデジタルファブリケーションを組み合わせたプロジェクトになります。非常にシンプルでミニマルなんですがここに一つの合理性があって新しい表現を与えていると。ここには何か違うこれまでと違う構造の表現というものがあるんじゃないかと。which are filled with aerogel. So it's a translucent facade. でこのパネルの部分ですねここも2枚のパネルの間に、こうジェル状の素材を入れていってそれがこう半透明で光を透過する素材になっていると。でそれを使うとこういう対立的なような不思議なパターンができてこういった自然のように見えるけれども物の物性でできているんですがコンピューテーションに作ってその人工的に生成されたパターンというものがこういった形でできることになると。こういう斜めにひし形になっているところがいわゆるガラスの窓になっているんですが窓の、本当に透明な部分とそれ以外の透過性のパターンがある部分違う素材感と機能とこれまでなかったような形というのがこういったことで、実現できる可能性そこを今探索しているということになります。ここからですね少しコンピューテーショナルデザインの文化カルチャーその全体の流れっていうことがいかにただでテクニカルなものに閉じるんではなくて今世界的にも一つのトレンドになっているサステナビリティサステナブルな建築にどう貢献できるのかということをお話ししたいと思います。サステナビリティみたいないわゆる環境とかそういったソーシャルな意識っていうのとコンピューターデジタルテクノロジーっていうのは二項対立的な扱いを受けてしまっていてなかなかその2つをうまく組み合わせていくのはなかなか社会的な通念上も期待値としても難しいわけですね。 でもその2つ違うものと思われているものをいかにこう組み合わせていくかっていうのが、必要なことなんじゃないかと思ってるわけですね。そこには当然テクノロジーだけではなくて社会的な通念概念とか、これまで慣れ親しんだものみたいなことにも当然、関わっていかなきゃいけないわけです。コンピューテーショナルデザインの文化カルチャーっていうのはをサステナブルアーキテクチャにうまく使っていくためには、デジタル、すみません、最後まで読めませんでした。未来の、見通しとしては、1、リバーシブルプロセスで、こう一方向じゃなくて戻ることができる可感性のあるプロセス、2番として、発見的な素材の利用で、3番として、仮想的に使うこう、デジタルバーチャルな、すみません、最後までいかなかったですね。1番です。いくつか、さっきの5つの要素をいくつのプロジェクトで実例したいと思います。これはロックプリントのパビリオンというんですが、どうやって作ったと思いますか？これは実は石の砂利の塊でできていて、その砂利はコンクリートに固まっているわけじゃなくて、紐でつながっています。紐が間に入っていて、その紐がお互いの石を止めているという状態で、いわゆるコンクリートとか石とかそういったものではないわけですね。砂利っていうのは当然崩れてしまうんですが、これだけたくさんの紐が中に入っていることで、意外にこうやって残るわけです。これが作り方ですね。砂利っていうのは意外に安定性があって、紐を間に入れてあげることで、糊も何も接着剤もないんですけれども、非常に安定的な構造を紐が間に入ることで、効果的に入ることで作れると。これの作り方ですね。壊し方ですね。上から順番に1本の紐で全部つながっているので、順々に上から紐を引っ張っていくと、その周りの石がどうやってこうやって外れていくと、接着剤を使ってないのが分かると思いますが、紐をこうやって抜いていくと、順番に最後にはただの砂利の山になってしまうということですね。ここで大事なのは、オリジナルの素材、砂利とか紐っていうのは何も変質してないわけですね。使った後には全く再利用が可能な元の素材に戻るという、これまでの建築にはなかった、一つのクオリティを持つわけです。砂利というのは一つの建築の素材なわけですから、こうやって再回収をして、また別の 3D プリント素材として使うことができると。そこには性能の劣化とか質の劣化というのはなくて、完全に同じ材料として再利用することができると。もちろんまだちっちゃいプロジェクトであるんですが、これには可能性がいろいろあると思います。建築が素材を変質させない再利用可能なものとして担保するような工法を探索していくというのは一つあるアプローチですよねと。
The tree to the right size, and I think it's correct for timber actually, but still, you actually intervene in the material as you find it, you produce the bricks, etc. It's nothing wrong with it, but how can we work directly with the materials as we find them? This research project here, our PhD student and actually also a PhD student from robotics.
これは次の As Found Material という素材をいかに発見的に使っていくかというプロジェクトで、これは一つの、博士課程の学生のプロジェクトなんですが、
Concrete waste will be the future building product which is available to us in the city. All the concrete buildings which are now built are going to become these concrete blocks. How can you build with those?
将来的にこういうコンクリートの塊、廃材としてのコンクリートの塊みたいなのがいっぱい出てくるわけですが、 建設行為というのはそういう廃材というのをいっぱい生み出してしまう行為ですと。でそれの石でもいいですし、こういったもの、解体された材料でもいいんですが、要は制御できないもの、もうどうしても生じてしまう与えられた形をそのまま使うということで建材に使うというアプローチができないかということをここでは考えています。面をスキャンをして分析をして、それらをどう組み合わせることで最適な配置として安定的な構造を作るかということを、与えられた素材の組み合わせの中から探索するということをやるわけですね。
And here you see then the environment with which our researcher worked. On the left-hand side is his computer.
これが、その、研究の過程ですけど、左がその博士課程の学生さんのコンピューターで、ここでいろんな組み合わせを検証しています。でその、組み合わせの最適化が探索されたら、それを右側のロボットのコントロールの画面に持っていきます。ここには、もうランダムな形の自然な形の石がいっぱいあるわけですが、ここには道具とか、そういった特別のガジェットを使わずに、構造を作っていくという、その構造が安定するということを計算した上で組み合わせていくので、それをやっていくわけですね。で一つ一つの石の、スキャンが終わったものをその、想定された配置に組んでいくということをやると、最終的にとても石を組んだだけとは思えないような薄い壁が、何の支柱も何の、支持材も使わずに組み合わせだけで作るということが、可能性になってくるわけですね。
And then we had the chance to build an 80-meter long wall with this process.
でこのプロセスで80メートルの長さの石の壁を作るということをやってみました。
Here again, this machine without the driver.
この、工具自体がこれ無人の自動操作の土木用の車両なので、これが一つのロボットアームもしくはデジタルファブリケーションの機械として扱っています。でそれを石の形を最適化させて、周りをリアルタイムでセンシングをしながらその計算された安定する位置に置いていくということを繰り返すわけですね。そうするとこういった石だけで組んでいるに安定する壁ができると。先ほどの石を紐で積んでたもの、あれはどこか何かコンピューテーショナルデザインをしたという感じが表現の中にある程度恣意的に入ってたと思うんですが、これの場合はもう一回できてしまうとデジタルに使われたということはほぼわからないというか、もういわゆる伝統的な工法で作ったのと違うような表現になってしまうと。デジタルなプロセスっていうものが必ずしも表現に、組み込まれている必要もないというのもすごく面白いところですよねと。3番目、拡張クラフト、オーギュメンテッドクラフトっていうことですが、デジタルに拡張をした成功方法と。最初に見せたワイナリーを見てこういうのが欲しいというのがあったんですが、同じプロジェクトは同じことはやんないよということをしたんですが、どうしてもああいうものが欲しいと言われたので、今度はギリシャのワインメーカーさん、ワイン畑のオーナーさんなんですが、じゃあもうちょっと違うアプローチでやってみようかということになりました。じゃあもうちょっとチャレンジとして、スイスですごく、手間のかかったレンガ作りの壁をプロデュースして、それをいかに、離れたそのギリシャの地で施工するかということに、チャレンジをしてみようと思ったわけですね。この場合は先ほどの ワイン、ブドウの房と違ってもうちょっとこう流動的なというか流線的なパターンになっているんですが、これの場合は、手で施工をしていきます。で、大体の位置にレンガを打つと、それをリアルタイムでセンシングをして、で、こっちが出っ張ってる、こっちをもうちょっと叩きなさい、こっちをプッシュしなさいという画像が、画像上にリアルタイムで出てきます。それを見ながら人間が微調整を機械の指示に従ってやっていくということをやっている。要はロボットアームとかを全く使わずにリモートにスイスからギリシャに指示を与えているんですが、そのリアルタイムに指示をするプログラム施設を与えることで現地のレンガと現地の職人が厳密なデータを再現することができるということをやってるわけですね。こうやっぱりここにはその職人の手っていうある揺らぎが入ってくるので、見てみると分かるようにロボットアームで作るよりもむしろこのモルタルの厚みの違いとかある程度こう手仕事ならではのズレが入ってくるんですが、それが一つの新しい表現になっていて、面白い効果を生んでいます。さあ次は AI 人工知能によって可能になるデザインという要素です。さあ AI がデザインする人工知能のデザインをどう可能にするかって何かちょっと矛盾というか変な響きがありますよねと。デザインっていうのはそもそもその機械に作ってもらうものではないはずなので、何かそこには自己矛盾があるような気はします。でもそこをチャレンジしてみようと思ったのがこのプロジェクトになります。これがこう5層に並んだプランター、植物のプランターの構造なんですが、ある住宅とか再開発エリアですね、都心の再開発エリアの中に入っているこうフォリーというかリサーチのパビリオンをパブリックアートとして設置するというプロジェクトになっています。Actually, we cannot do a small project because if you know how big these developments will be around it. で、そのプロジェクト、そんなにちっちゃいものにはできないと。都市の再開発の一つのシンボルなので、それなりのスケール感を街に相応なものとして持たなきゃいけないということで、やっぱり規模とかシンボル性みたいなのを持たなきゃいけないと。もともとその大きさのリクワイアメントに加えてその街のシンボルというかみんなの拠り所としてグリーンであること、植栽があるということはもともと求められていたので、それをどう入れ込むかということがテーマになりました。でそれをアプローチするにあたって日光への露出、雨をいかに受けるかとか、そういった自然の植物を育てる上で必要な要素をパラメータに落とし込んで、それによって形態を探索して、いろんなパターン組み合わせを探索させ生成させました。ルールに基づいてその日照とか給水とかそういったものをうまく最適するような可能性のパターンを探しているわけですね。でいくつかのパラメータをじゃあ一つのユニットの大きさをこういうユニット単位に変えますよっていうと、こういって自動的に組み合わせを作り直してくれると。じゃあもっと雨を受けやすいようにしなさいというと、こういうふうにして違う形が生成されると。でそれをある程度やっていくと、システムの方がどういう時にどういうソリューションを出したらいいかということを学習をして、我々の指示をしなくても一定の条件に対する形を生成できるようになってきます。こうやって雨の露出をちっちゃくてもいいよとなると、構造が上部に通ってくるので構造的な合理化ができるというふうになると。いろいろそれぞれの目的をどう優先するかで何が最適で合理化されるかでの当然変わってくるんですが、その中で 自分たちが設定したルールと方向性ではあるんですけれども、当初想定してなかった、予想もしてなかったような形が、発見される、提案されるという状態が出てくると。これは非常に面白いことなんじゃないかと思うわけですね。で最終的にある判断でこの組み合わせがいいというものを、選択をします。でこう一度決まると、その形のユニークなジオメトリーを、ロボットアーム、デジタルファブリケーションによって、厳密に切り出して、ロボットによって組み合わせをして、この工法自体も通常の、組み合わせ工法ではなかなか難しい、作り方になりますが、ロボットアームを使うことで、この角度を同時に止めて、そこに接着剤を入れて、
It's a very special glue which can actually take these forces. So it then acts as a complex.
でこの特殊なシェル構造をパネルの組み合わせで作るというのに最適なその浸透性の糊を使い、接着剤を使ってそれをある一定の力で押し付けるということをキープできるような工法ならではのシェルの作り方で最終的な形を作っていきます。
Then these pots get assembled.
で一旦これがもう組み合わさったものをクレーンで積んで、現地で施工した状態がこれになります。
So you see in this project it was more about accepting also how we collaborate with the digital processes.
ここで見てきたように、これはいわゆる我々が全部コントロール制御しようとするということではなくて、いかにAI もしくはデジタルプロセスというものにある程度の自由度、提案力を認めて、いかに相互に協力をしてデザインを進めていくかという一言のアプローチの事例になります。5つ目の要素ですね。リバイスドアーバニティーって都市のアーバニティというものがもう一度再解釈されるということなのかなということですよね。
I mean, you have good precedents here in Japan of architects that have attempted this. So this city is 600 meters high, it has 300 meter diameter, and it can have population of 30,000 inhabitants.
これは一つの仮定的な、仮想的な都市になるんだと思うんですが、超高層の垂直の都市ということに一つの仮定的な、パラメータを与えています。アーバニティ20世紀以降の都市問題というのはスプロール、どんどん、拡張してそれが刑事的に社会問題になっていくと。それに対して一つのアプローチになっていると。これフランスの郊外の TGV の新幹線のすぐ横にある一つの郊外の村なんですが、非常に静かな落ち着いた村です。一つの実験としてこのドローンによって、ミニチュアの仮想の高層都市の、ユニットとしてのブリックを積んでいくということを、一つのこれもちろん物理的に成り立たないのでファンタジーではあるんですが、そういったことを仮に将来できるようになった場合にどういう垂直都市ができうるのかということをやっています。この1個のブリックがですね、模型なんですけれども3階建ての建築ユニットだと想定して、それをどう組んでいくと、一つの郊外型の、環境にうまく適合した高層住宅っていうものがこういう工法と、フォームファインディングの結果としてあり得るんじゃないかということですね。でこれがあることで空中の心地よいレベルで空中庭園があって横につながっていくような、確率的じゃないユニットの粗密の違いみたいなこともデザインできると思いますし、こうなってくると空中にいるんだけれども、むしろ 植物と近くて、歩行者フレンドリーな街というのがむしろこういう形の方ができるんじゃないかということを考えているわけですね。断面とか模型の写真ですけれども、これは垂直の仮想的な歩行者フレンドリーな一つの垂直都市な惑星ですけれども、
village atmosphere there, but of course you're also in wider environment. You can go to the countryside, you can take the train to Paris in an hour. So you're still
その郊外の、ならではの環境というのを十分以上に普通よりも楽しんだ上で、TGV の横なのでパリにすぐに行けるしというようなアーバンとルーラルが合わさったような環境がこうやって多くの人に提供できるんじゃないかと。でこれの施工のシステムの実験ですね。ドローンが一つ一つのユニットを取って正確にロボットアームの代わりとして与えられた場所に積んでいくということをやってるわけですね。もう超高層であれば当然クレーンとか仮設の足場とかが普通必要になるんですが、そういうもの全くなしに建築物が自らどんどん積み上がっていってもう構造として成立すると。これがその町のこの市長さんなんですが、この模型ができた時にすごく喜んでる時ですね。これまでのいわゆる建設という概念を過程として作り方としてあり方として変えていく可能性がこういったものの先にあるんじゃないかと。これは一つ何ですかね、コルビジェ的というかモダニスト的な超高層ビルを一個田園都市的に建てるというのも、ある意味20世紀的なパラダイムかもしれないですが、ただそういうものに限るわけではなくて、こういった技術的デザイン的なアプローチがあるんじゃないかと思っています。皆さんありがとうございました。
Thank you. So, and very clear description of each project. What was your intention? What was your ambitions? And how you execute it? And I thought it was very nicely presented. So, what the remaining time? We're gonna have a discussions. And I don't know. This should be more a QR session after Q&A session, or if you have any urgent question that you wanted to ask, I think you can just jump in and ask a question, I feel like. So now I just wanted to start asking Matthias, since this is rather informal, however, you have used the word research quite often. And I don't know how many of people here in the audience are architects or architectural students that wanted to pursue that profession. But conventional, maybe not a wisdom, but typically the researching architectures are not on the same page. However, perhaps that has changed in the past. But when we say research, more scientific research, we are looking into molecular structures, that kind of white lab coat. But your research seems to operate in a very different way. So how do you draw the bridge between a research and a creative innovations? Because research, in my opinion, has to be very objective. The results are repeatable, and the result can be shared with a larger societal. So it's not an individual pursuit, it's a collective pursuit, but at the same time, architecture tend to have a personal. Tadao Ando, Kengo Kuma, those are kind of star architects that have a signature. So I just wonder, how do you articulate both kind of research and the creative practices?
ここからはもう訳さないですけど、リサーチって言葉をいっぱい使って、その研究っていうすごくサイエンティフィックに聞こえることと、デザインっていうすごく主観的なものって 違うものとして捉えられたけど、それをどうつなげて、それをどういうふうに紹介しているのかということですね。
But I think over the years we have developed a certain, let's say, certain methods on how we bring this together. So originally we were design practice, an office, and at ETH we did certain experiments. I would call it research light, kind of experimental studios, tests, but we were not doing scientific research. And then we realized, to push this further, we actually need to engage in scientific research. We need to write scientific research grants. We need to basically level up our game as architects to kind of establish a certain presence in the research domain. And so then we started, basically looking for grants and also starting PhD research. And so this in a way professionalized in some ways. And so now about many of these works or parts of these works are also things which I have not shown. You can read research papers, which describe you in technical details, how it is done, which you can try to replicate if you have some robots at hand. And where you can actually, you have this kind of generalizable knowledge at the hand. At the same time, I think as architects, I think doing projects, doing project-based research is a great asset. I think many times researchers have the problem, it's very hard to communicate what they do. What is the societal relevance? By architecture and demonstrating architectural buildings, immediately we have a direct societal exchange. We have exchange with companies that help us realizing this research. We have exchange with future users. We have reactions from press, etc. So we have a different kind of feedback than we have from the research community. And the researchers learn a lot from this transfer process. And we learn a lot, from the research for doing architecture. Almost to the point where I think maybe researching could be a way of doing architecture. And so this is a bit, the mechanisms which have established over the years.
But is that, do you see many architects should be in that domain, or this is a particular method of your design practice that use those research-based approaches?
I would say currently it's probably more, I think as a research practice, I think it starts to become more and more established. So I think I see many universities that build demonstrators, that engage actively with technologies, that buy robots, so I think that is, I hope that our field is able to say, let's say architectural design, for example, maybe it could be in other industries, is able to say, these are our research methodologies, and we define them as our methods. I think that would be very nice. So it's not second-hand research, but it's the research that is relevant to our domain. For the design practice, it's a bit more difficult because the design practice often does not have all the means that the research institute had, but it has other freedoms. It can work on larger projects, can work in faster pace, or needs to work in faster pace at projects. So there is,
Which profession, architect, researcher, and educator that you are, which part you like the most?
Everything. I once said, after the studies, I was very confused. I thought, what am I going to do? And I didn't have a commission or anything. And I wanted to open my office, but without a commission. What do you do, etc. So at one point, I just told myself, whatever I'm doing, I'm going to do it as an architect. So I'm going to be an architect, or whatever I do is architecture. So that's what I do. So I just call it architecture. If So I don't want to be in a specific domain.
But which one you enjoy the most?
Does he need to choose? Architecture could be a broader sense in a way through this kind of process, right?
Exactly.
Yeah.
I think we don't need to. I think it, in a way, maybe more provocative. I think it's really a problem that we are separating all these domains so heavily.
Right.
And we sense it in university. We sense it a lot, right? Because there is a department, for robotics. There's a department for biochemistry. And then it's very hard to collaborate between those departments. I told the president of our university, maybe you should abandon the departments. He looked at me like, I think it's not helpful.
But still, you need a name. Otherwise, people wouldn't recognize what it's at. And there is certain tendency and gradation that you have to be able to recognize and differentiate and choose.
Yeah, choose.
Okay. They need to dig in and then just figure out.
I think it's good to choose. I mean, it's good to choose your identity. So it's good for me. It's good to say I'm an architect. I could also say I'm a designer. I can also say I'm a researcher. I don't mind so much.
But for instance, when I'm teaching in that kind of more free kind of university without having a definition and department, I mean, there's some kind of universities like that. But at the same time, I face the kind of fundamental problem that there is no fundamental kind of technical base skill, or let's say mathematics or some linguistic skill or whatever. And then the quality of education could become lower. That's a fundamental issue too. So it's kind of like a trade-off.
Okay.
How would you deal with it?
You touch a good point, and we currently at the Department of Architecture, we're in a curriculum revision, so we have a lot of debates about this. I mean, you're correct. I think there is basic skills which we need to learn and embrace. But I think it's not the same as having a very narrow definition of what a trade is. It's not helping so much. It's more helpful to understand what do I need to know today to be, I don't know, to be an architect, to design today. I would argue, I mean, we just discussed before about also, virtual space, etc. I think, for example, digital literacy is very important. But at ETH Zurich, we don't teach it yet. We start to teach it.
There's no official course of such a thing?
No, this is in the research corner. So we now need to bring it to the general student body. And we started now two semesters ago to do a so-called immersive design studio where students design with computational design and VR, etc. And the learning curve is really fast. It's great. I mean, people are really ready for it, but I think you need to offer it. It's a bit of a generational question.
Can I ask you one more question that, before handing over to you guys? Let's say that it's a hot topic, ChatGPT and then GPT-4 and stuff. And then that, I mean, computer used to belongs to mathematics and science and then kind of numeric control, formal control, geometry.
Yeah.
But now you can describe some kind of literature in a way. And you can generate the form, generate a certain kind of even a program, and that could generate some form. How would you approach that, and how would you perceive that kind of more like numerically, controlling control kind of thing?
Yeah.
Vague and ambiguity. Oh, sorry.
I'm not very worried. I think it is just a new development. We need to get used to it. We needed to get used to other technologies in the past, and we are pretty good at it. I think, again, the literacy is important because, for example, if you look at image generation techniques, Midjourney or etc., you see that they are fantastic, in producing images because they've been trained on so many images, which is actually a collective contribution. So we need to pay a bit attention. Well, who is delivering the data to actually produce this intelligence? But in a way, it's producing images. And now as an architect, I say, well, images could be a base for producing architecture. I personally don't think, that was what I was trying to show, that it's the most relevant base for architecture. So I think, for example, the image generation techniques, for me, it's not very relevant to architecture, although I know many architects playing with it and creating fantastic renderings, etc. For me, it's a not interesting direction, personally, for example. Yet, what happens if you can start to create spatial structures with these processes? That's where Semiramis is a try in this direction.
Right.
I also spent my sabbatical actually doing some machine learning. I wanted to learn myself how to do it. So again, about digital literacy. And then how can you build such systems and how can you design with it? What's the creative impact of it? That is very interesting. But I think we need to bring that into our design domain. So if you're a graphic artist or an industrial designer or an architect, etc., you need to think, how do you want to, what's the real relevance beyond the hype for your, and then you also need to take a personal stance on it and maybe create your own processes. I don't think it's so interesting to just use software which is given to you. It has always a very strong bias, whether you use AutoCAD or ChatGPT.
It's really packaging into.
It's always a package,
right?
And if we want to fundamentally contribute to the, to our built environment, to where we live in, we also need to fundamentally understand it and interact with it. And I'm not sure if through a package is the best access. Of course, we also use all kind of packages, so I'm not saying that's cannot be helpful.
It's maybe this is a bit of comment, but what you're saying seems to be very consistent throughout your entire career. Like the use of robotic arm, that was developed for the auto industries, and that was fixed movement that they can do very high efficient production processes. But you hacked it to the point that all the robots are meant to do a repeated processes that becomes highly adaptive a design tool. Because when I saw the first time back in 2000, maybe even before 10, I think you start using it and everybody thought, gosh, why didn't I think that? You know, and for me, that's the kind of interesting creative moment, that the tools are not meant to just to do what was designed for, but how do you actually either misuse or use it in a different way that opens up the entire domain of creative practices. So it seems to kind of a consistent that what you do and what you're just saying, that you're not bound by these given the tools and softwares and devices.
I mean, exploring the tools is also cool, right? I mean, it's also fine, but I think it also, I mean, tools are always like platforms, right? It's like, I don't know, if you have
just nest building.
Yeah, you have a hammer back home, or you have certain things around you, and of course you need to think through what you have at your hands. At the same time, it makes sense that you understand what tool you have. Otherwise, you just do anything.
And this is perhaps a naive question, but how do you convince people to join your project? Like you have roboticists, chemists, a whole set of industries and professions seems to be very convinced and wanted to work with you. Are you making a pitch?
Well,
or you are, what's the chemistry for your collaboration with such a wide range of experts?
I would say maybe.
Or is that a Swiss thing?
No, maybe two things. One is I think there is curiosity in our work. So I think, yeah, as I said, we don't repeat projects usually. We're just curious, and so I think some people are also curious. Other people are not curious. So this divides, let's say, partners probably. And then I think what we also try to do is we do it for real. So I mean, a project like the one on the screen is it's not easy to work with these different specialists and to bring it all together and still do architecture with it, etc. It is always a fine line. I enjoy it a lot, actually. Particularly, for example, this project was great, but it's a fine line, and but it's important to bring it to an end, because if you don't realize the project, if you cannot pull a project through, then people in a way also don't believe in you, right? I think it's important that you can commit and then you do it and you really do it. And sometimes it's hard. I mean, for example, for the researcher, I think now, for example, of Daniela or Fotini, who had been in Greece for 3 months.
That sounds nice.
With the craftsmen, yeah, but yeah, doing multiple thousand bricks and debugging, etc. It was very hot. And then I'm in quite a luxurious position, right? Because I go there once, I lay a brick, I think it's great. So I mean, there is a lot of commitment from our team, and I'm very grateful that there is. So the people are very driven to also find out and contribute to this joint endeavor. So it's not myself alone or Fabio Gramazio alone. It's it's a lot of people that share this passion and think that something new will evolve out of it. And I think there also sustainability is important, because I think it gives an interesting mission to the digital, because the digital at one point had a bit became a bit like an aesthetic exploration for self-purpose. And I think while it is very fascinating, I still like the digital also for its own aesthetics and its own capabilities. But I think it's important to give purpose, in the social, in the material, in the world. Yeah.
In that sense, it's kind of like a mean question, but sustainability is just an excuse or a purpose, or is that the ultimate goal of the digital fabrication? It sounds like a sustainability is the something substitution for aesthetic or something, but
no, yeah.
How serious are you with those two?
I think we get more and more serious, but it is true that we didn't start there. So, I mean, I need to fully acknowledge that we were just super fascinated by the computer, by these tools, by the robots, by what we could do with the materials. That's also what I show, right? The winery wasn't about sustainability. Very nice wine, though, but but on the other hand, we also need to pay attention. I mean, if you craft something beautiful and people love it, it is also very sustainable. So I don't think I wouldn't say good architecture is only if you calculate the CO2 values and then check and then it's good architecture. No, I don't think. There is a complex relation in how we conceive architecture. Aesthetics is a big part of it. If a building is loved and stays longer, it has a high impact on sustainability. If a building is not loved and is taken down after a few years, it actually happened to some projects of us, it's very unsustainable,
right?
Because the CO2 emission is over the lifespan of a building. So it is a complex relationship. But I think in the essence, for us, we've always been working between materials, fabrication, and computation. So the material aspects are directly linked to sustainability. And therefore, rethinking those processes from sustainability point of view for us is a very natural process and very exciting.
So you see the more future of the computational going to be a fundamental contribution for sustainability?
Yeah, I think so. Right. I actually think that, I mean, look at this ceiling, right? This stuff here. I mean, probably the world is too complex to undo this. Like in a way, we would like to all live in buildings that don't have, all this complexity, but it's not so easy to unwind. So probably we need to also be able to deal with complexities in a new way. At the same time, also dare to be simpler. I think we need to come from all sides, and we need to have many, many more experiments and trials from different designers and architects and thinkers to figure out what is the right way forward. But I think we need a quite fundamental transformation.
Sure. Are there any questions from, we can keep talking, but there are some questions, could be casual questions.
Any candid opinion?
Serious question.
Provocations.
There's one over there. マイクが行くのでちょっと待ってください。
Thank you for your wonderful lecture. There's an aspect that computational design pursues freedom of architecture and special shapes. But I think it is also important to the method of adaptability to existing market material, or a kind of the module to have scalability and cosmate. So how do you think boundary or composition of architecture freedom and order through the computational design? Thank you.
I'm not sure if I fully understood the question. So you say
Maybe the transition between the existing building industry and then the existing kind of
existing building industry of today or the past?
既存の建築とのトランジションをどうするかみたいなことですか？
And existing market materials.
Now.
Now, yes.
Everything could be brand new and a completely new system, or you need to kind of adapt through?
I mean, both is possible. When we work with bricks, you work with current systems. And of course, you can automate also current processes. You can say, okay, I don't know, how do you, I mean, just had some presentation. For example, how do you, I don't know, spray the fire protection on with the robot, how to lay a floor, etc. I mean, this is all, in a way, exciting technical developments. For me, architecturally speaking, not much happens. So as an architect, I'm interested that the industry evolves towards digital craftsmanship. So that is interesting. At the same time, architecturally, it doesn't change anything. So I think the real challenge is to architecturally think about this collaboration with machines and say, what does it want to be and what does it want to become in the sense of a sustainable architecture? So I'm not sure if that answers your question. So we did examples, for example, in Singapore, we developed with someone from our team developing a tiling robot, because that was very interesting also in that local context, etc. But that goes into robotics. It goes into robotic automation. And I think in the future, we're going to see many more building robots. It's going to happen. But as a designer, what do you do with it? That's a good question. And is the system then locked in the certain, I don't know, tile size, certain material or not? Or can the system also be reinterpreted, reused maybe in creative ways? So sometimes a machine like the industrial arm robot can be easily reused in different ways. And this could be the same. If you have a tiling robot, for example, maybe you can rethink what you can do with it, and suddenly it becomes very purposeful for your project. Is that answering your question or completely beside the point? Okay, good.
はい、日本語でもいいですよ。この訳すので気兼ねなく。
So I'm not an architect. So first time seeing such thing, very interesting. So current industry practice, so design house will design and then hand over to like a contractor, and then construction house do the planning and construction work, so on. But would you consider like, machines and computer can take over that construction company so the design house can do from beginning to the end? Do you think that's going to foresee your future?
Yeah, I think if we design the way that we currently are trying it, basically you design the making. You design with the idea of how it's going to be made. And I think in traditional design, you have always done this. I think good architects have always thought about how to make something when they design it. But now, in former times, this was implicit. You think about it, you have a good guess, and then the contractor does it, and then you approve it or not. But now it's explicit. If you design or maybe even code, write the program about your design, etc., then there is data which becomes execution data. So it's very direct. So what this means is you need very early on, you need a different model where experts like structural engineers, other planners, and also fabricators are discussing with you during the design, and you start to find out what are the relevant data and parameters that are influencing your design and what are you needing to produce. And I think it's a different model of organization which is required, and the reality is not fully there yet. This will need to change.
Excuse me for just one more question. So I thought this kind of process would be so much easier for like a building owner or the project owner to understand, what the design architecture is thinking and what will be the output, right? So how would you communicate with like building owner or the property owner? How would you, their concerns or, their own interests, how would you incorporate into your design process?
This is a very good question, and I think I did not show this here. We have some also design projects which address this very directly. What is nice about these computational design processes is that you can design them in a way that multiple people can participate. So you can share the results, you can share the 3D model, with VR or whatever devices. You can be in the same space virtually, etc. But you can also say, okay, if you as a client want to decide something, maybe you want to co-design something, you can say, okay, let's integrate this into the design. We did some experiments where we actually said, okay, as architects, we are interested in controlling this, this, and this, but maybe our client, this was, for example, for an exhibition, we said, actually, they can decide on part of the form. But it's all woven into one design system where the aesthetics and the kind of the principle of design is still strong and decided. So it's not like a Swiss muesli, it's not a mix, but it's carefully crafted together. So I think computational design is also a possible model for collaboration. Sorry, it's a bit abstract. I would need to show it on a project to show this, but yeah. You're welcome.
他に、はい、どうぞ。
So thank you for your presentation. So my question is that I'm currently doing the project that making a furniture with the wood that is normally not used because it's kind of bendy and like very thin. But like the one problem I always have is that we have to transport the wood to the those we have a CNC at the university, but we have to transport the wood from the forest to the factory with the rush cutting machine, and then to go to university to use a CNC and then go back to the original place. So, but I also see that from your presentation that like utilizing the drone technology or like the other technology, we can like do it on site. So do you have like a brighter future about that, or do you think we still have to rely on those transportation?
Yeah, it's a good question, but there is no easy answer because that's really then about calculating the footprint. And I'm not an expert there, but we work with people that can do that in delicate ways. Usually from what we found is that digital fabrications are running, for example, a robot or a machine, and transport is usually not the most critical part for CO2 emission. The most critical part is how much material do you use, what material do you use, and how long is it used. So how long does a building stand, or is your furniture used and usable? And then what material? And so I think these are more critical parts than transportation and fabrication. That's generally, you can say it like this, but then it depends on which process that you're using. We have, for example, right now, I did not show this project, we are shooting clay, bullets into one another to build clay walls. And there we have a discussion. This process needs quite a bit of energy. There we have a discussion, maybe the fabrication could be critical for the sustainability, because clay is very sustainable, but here we have a lot of energy. Also, flying with drones is very energy intensive. So flying the timber from the forest to your factory is also not so good, for example. So it's complicated. We will need to discuss a specific case. Yeah.
他に questions or any comments or not? I can also ask a quick question. Why are you still thinking? So you come to, even though the COVID disrupted, but you've been coming to Japan quite often in the past. And maybe this is my personal understanding. Digital fabrication and also computational design, it's not the most strongest Japanese architecture, and also in the part of the education. Partly because I think there's a strong craft tradition that exists in Japan that not necessarily rely on digital technology in order to achieve the quality. Whereas other countries, perhaps this will really help to advance in terms of quality and also the control of quality. So my question is, what advice do you give to a Japanese architects, students about heritage or understanding a tradition of the craftsman, and how that kind of lead into your world of digital craftsmanship, if you like? How do you kind of give advice if you were to be able to give?
Well, I'm not sure if I know enough about Japan to give advice here. But I think, I mean, if you have great craftsmen, it's perfect. So work with them. So I think this is, I mean, the human is always the most important ingredient in collaboration and in interdisciplinary collaboration. And I think you have a very, very special culture here, because you also have, this entire, I don't know how to call it, kind of gamified kind of culture at the same time. You have also, there's very serious but also very playful aspects. And then there is a very strong traditional crafts culture with very high sensibility and attention on material qualities. And I think in my fantasy, I always think this is the perfect country, you know, to bring these topics together. But I assume these are quite separate realms, right? The people playing around with robots or with the latest technologies and the craftsmen. But I think this is what we have been trying in Switzerland, to actually start to weave these different communities together, and also offering our work as a platform where this can happen. And I think here you have fantastic ingredients. It would be really great to, I mean, I have no other advice than to talk to many people from the different sides and see if they would like to collaborate. I'm pretty sure there would be quite positive responses.
Good.
Can I take advantage of their silence too?
Yeah.
Very candid question, and then just not for their sake, my own sake.
Okay.
How can you find a client through this kind of project? I mean, it's really difficult to find a project with a lot of challenges, technical challenges, and what things are right. Let's say this is right direction for society to go, and right technology to adapt, and right things, this and that. Environmental, whatever. But eventually, client wouldn't buy it. Most of the cases. And how can you find clients like this or this type of project? Eventually, is it an aesthetic and fun, or still you need to convince the client that this is the right thing to do? Could that be a sell?
So there is a not so successful and a successful story to that. So the not so successful story is our office, because basically the research was so successful that we stopped our office. So right now we don't have an operating office. It's still there's still written on a door, and it still exists, but we're not active in the office. But what we found is on the research side that we could do projects like this one, for example. Actually, all the projects that I've shown we could do through the research, so through university. We found a different model on how to operate. And there, actually, the good thing is the client come to us by chance, by interaction. So we're not looking for clients anymore. We don't have a lot of works. We do maybe, you know, one such a project maybe every 2-3 years or so. So it's relatively modest. But cool. So currently I'm quite happy with it, but I miss a bit the office, I must say, because in the office there were many more projects ongoing in parallel, which was also interesting. And of course the office could also do larger projects. You know, with the university we could not do a larger development, a larger housing complex or high-rise or whatever. You could not do it with the university. So we stay roughly in this scale of project, which I have shown you, which makes sense with the university. It's quite luxurious situation, but I don't have the answer for the professional practice. Maybe we're gonna open the office again. I don't know. Let's see.
Maybe the time.
And I come to you for advice.
I need your advice. That's very helpful. Any question? 日本語でも大丈夫ですよ。
はい、お願いします。
Thank you for your great lecture. If I can say, I see you as a great fabricator as well, doing this kind of really challenging projects and making it true. But I think in the same time, I think there's behind the scene, there's lots of challenges must be, because I think it doesn't work as what Grasshopper is showing and in the real world, I think, right? So I want to know if you have any, like, your personal principle or personal thought kind of to challenge these kind of really complicated digital fabrication project, how you like killing like tolerance, or how you kind of matching the detail? Do you have any like overall like technical your thought before starting those kind of projects?
For your information, have you been to Fab Cafe in Shibuya?
Yes, I have.
He's a master
a
up there.
lot of years, many years ago. Yeah.
Yeah, but that's why he's questions from.
Okay.
He's master from there.
And so your question is if there is, or how to approach the technical difficulties?
Yeah, how to challenge the technical difficulties, or you must overcome lots of challenges. So if you have any overall thought.
I think in a way, what's most important for me is in a way to stay a bit agile. I'm not always very good at it because I also like to plan a bit ahead, but the planning gets you stuck sometimes. You want something like this. Sometimes you need to be persistent, but sometimes you actually get stuck. And so it's actually interesting to attune to the problems and say, okay, what does this problem want to tell you? And maybe there's much easier ways which still yield a very interesting, design outcome. And so, I mean, taking this picture, for example, this is produced from flat timber plates. So we knew we had this kind of roundish planters, but we knew we're going to build them as polygons. And we needed to work actively on how can we not be deceived, because we designed it with this kind of round machine learning model. And we worked quite a bit in understanding what characters these polygons should have. So it's not only triangles, it's 3 to 5 sided polygons, irregular shapes, etc. So we needed to work towards this aesthetic to then be super pleased. And now we would not, if we could have this, CNC milled all around, we wouldn't want it, right? Now we want it exactly like this. So I think it's going towards the constraints, working with those, and then appreciating those, kind of relaxing into, making it easy in a way, and accepting it as the design. Yeah.
Thank you.
Does that mean that eventually, ultimately, the still aesthetic is some binding element of doing this kind of?
Aesthetic is always part of the profession, if there is still this profession. Okay.
How are we doing time? It's a little past 8. Perhaps maybe one more, if there is one, or this is too much of a pressure.
Doesn't need to be the best one, but the last one.
If not,
I would like to do something. There is one.
Okay. I was interested in what you wanted to do.
Yeah, I'm going to show you.
Thank you for your lecture. And I'm not sure this is the best question. I don't think so. but I'm now working at the architecture design firm, and I also do like computational design. And
which firm are you working for?
At Takenaka Corporation.
Okay.
It's a very specific Japanese.
One of the 5 GCs.
Mm-hmm.
And sometimes I struggle with the problem, the balance between optimization and the human will. So, for example, when I do the environmental simulation, my Rhino grasshopper says this is the best answer. But when I see the top 10 perspectives, I like the third one. How do you deal with those kind of situation or problem?
Choose the third one.
Oh,
No, honestly, I think, I mean, we had this conversation a number of times. I don't think design is an optimization question. I think optimization is an engineering approach. And I don't want to oppose engineering versus design or so. I think we should actually collaborate very tightly. And optimization is a very useful technique. But in order to do optimization, you always need to choose one parameter, maybe two, maybe three. If you need to optimize for 7, 8, 10 parameters, you cannot do it. It doesn't work because it becomes unclear. You need to weight these parameters, but how do you weigh them? So it becomes arbitrary. It becomes again your human design choice, how you weigh them. This is why for Semiramis we only choose 3 in the end. We tried with actually 4, 5, 7, and it got very confusing. You could not design with it. So you actually need to choose what you optimize for, which means optimization in a way is a very narrow perspective on each architectural project, because how many parameters does an architectural project have?
Millions.
Wow, that's a good one. So yeah, a design has many parameters and they change over the design process. Right? In the beginning, you think about those and those parameters and they change. So I think optimization is very helpful in specific instances, but it is not to be confounded with the overall design. Design is not an optimization question alone, but it's a part of the toolbox of the designer to optimize things.
Thank you.
Great.
Very much.
So are you going to show something?
Yeah.
Okay. That's good.
I was looking at this thing the entire time. Can I play it? Then I would like to formally close. Is this okay, or is this cultural problem? Can I? Good. Wow. This looks amazing.
Great. Thank you. Thank you. Okay. I don't
Thank
know
you
how
very
it
much.
goes.